The National Electrical Code prohibits the use of plug fuse-shaped breakers in place of fuses. Plug fuse-shaped breakers are not designed to provide the same level of protection as fuses, and their use can create a safety hazard. The destruction of a fuseholder typically occurs when someone uses excessive force when attempting to remove a Type S adapter. Type S adapters are designed to be removed with a simple twist. If the adapter is stuck, it is important to use a proper tool such as a pair of pliers to remove it. When a fuse blows repeatedly, it indicates there is a problem with the electrical device connected to that circuit. It is important to have any electrical device inspected by a qualified electrician to determine the cause of the problem. To ensure electrical safety and code compliance, it is essential to use the correct type of fuse or circuit breaker for the application. If a fuse or circuit breaker is blowing repeatedly, it is crucial to have the electrical system inspected by a qualified electrician to determine the cause of the problem. The National Electrical Code establishes safety standards for electrical installations to protect people and property from electrical hazards. It covers various aspects of electrical systems, including wiring methods, overcurrent protection, grounding, and equipment installation. When working with electrical systems, it's vital to adhere to the NEC guidelines and local electrical codes. Overcurrent protection devices, such as fuses and circuit breakers, are designed to protect electrical circuits from excessive current, which can cause overheating, fires, and equipment damage. Fuses are one-time use devices that melt and interrupt the circuit when the current exceeds a specific level. Circuit breakers are reusable devices that trip and interrupt the circuit when the current exceeds a specific level. There are different types of fuses and circuit breakers designed for specific applications and voltage ratings. It's essential to use the correct type and size of overcurrent protection device for the circuit being protected. Type S fuses are designed with a specific rejection feature to prevent the installation of fuses with a higher amperage rating than the circuit is designed for. This helps to prevent overloading and potential fire hazards. When replacing a fuse, it's important to match the voltage and amperage rating of the original fuse. Using a fuse with a higher amperage rating can overload the circuit and create a fire hazard. When working with electrical systems, always de-energize the circuit before performing any work. Use a voltage tester to verify that the circuit is de-energized before touching any wires or components. Wear appropriate personal protective equipment such as safety glasses and insulated gloves to protect yourself from electrical hazards. If you are not comfortable working with electrical systems, it's best to hire a qualified electrician to perform the work. They have the knowledge, skills, and experience to ensure the work is done safely and correctly. Electrical problems can be complex and dangerous, so it's always best to err on the side of caution. Ignoring electrical problems can lead to serious consequences, such as fires, injuries, and even death. Regular electrical inspections can help identify potential problems before they become serious hazards. An electrician can inspect your wiring, outlets, switches, and other electrical components to ensure they are in good working condition. They can also identify any code violations or safety hazards that need to be addressed. Maintaining a safe electrical system is essential for protecting your home and family. By following these safety tips and seeking professional help when needed, you can minimize the risk of electrical hazards. Remember, electricity is a powerful force that should be treated with respect. Never take shortcuts or attempt to perform electrical work if you're not qualified to do so. Always prioritize safety and seek professional help when needed. Using the correct tools for electrical work is just as important as using the correct components. Insulated tools are designed to protect you from electrical shock when working on energized circuits. Avoid using tools with damaged insulation, as this can create a serious safety hazard. When working with wires, use wire strippers to remove the insulation without damaging the conductor. Use crimping tools to make secure connections between wires and terminals. When making wire connections, ensure the wires are properly twisted together and secured with wire connectors. Loose wire connections can cause overheating and potential fire hazards. When installing electrical boxes, ensure they are properly grounded to provide a safe path for fault current. Grounding helps to prevent electrical shock and equipment damage. When running wires through walls or ceilings, use cable staples to secure the wires and prevent them from being damaged. Avoid running wires through sharp edges or areas where they could be exposed to physical damage. When installing lighting fixtures, follow the manufacturer's instructions carefully. Ensure the fixtures are properly grounded and wired according to code. Avoid overloading lighting circuits with too many fixtures, as this can cause overheating and potential fire hazards. When using extension cords, use heavy-duty cords that are rated for the intended use. Avoid overloading extension cords with too many devices, as this can cause overheating and potential fire hazards. Inspect extension cords regularly for damage and replace them if they are worn or frayed. Never run extension cords under rugs or furniture, as this can trap heat and create a fire hazard. When using portable generators, follow the manufacturer's instructions carefully. Ensure the generator is properly grounded and located in a well-ventilated area. Avoid running generators indoors, as this can create a carbon monoxide hazard. When using power tools, always wear safety glasses and other appropriate personal protective equipment. Avoid using power tools in wet or damp conditions, as this can create an electrical shock hazard. Inspect power tools regularly for damage and repair them if they are not in good working condition. When working on electrical equipment, always disconnect the power supply before performing any work. Use a lockout/tagout procedure to ensure the power supply remains disconnected while you are working on the equipment. Test the equipment to verify that it is energized before touching any wires or components. When troubleshooting electrical problems, start by checking the simplest things first, such as blown fuses or tripped circuit breakers. Use a multimeter to measure voltage, current, and resistance to help diagnose the problem. Follow a systematic approach to troubleshooting to avoid wasting time and making mistakes. When repairing electrical equipment, use only approved replacement parts that are designed for the specific equipment. Avoid using generic or unapproved parts, as this can create a safety hazard. When making electrical modifications or additions, obtain the necessary permits and inspections from your local building department. This will ensure the work is done according to code and meet safety standards. Keep electrical panels and equipment rooms clean and free of obstructions. This will make it easier to access the equipment for maintenance and repairs. Label electrical panels and circuits clearly to identify the circuits they serve. This will help prevent confusion and make it easier to troubleshoot problems. Educate yourself and your family about electrical safety. Learn how to recognize potential hazards and how to respond to electrical emergencies. By taking these precautions, you can create a safe electrical environment for yourself and your family. Remember, electricity is a valuable resource, but it can also be dangerous if not handled properly. Always prioritize safety and seek professional help when needed.